Yo DJ Tuesday, give me one of them funky ass beats. Oh yes, that's some funky shit. I'm about ready to kick this motherfucker in. You all ready for me to drop some science on your ass? Check it. I am the mighty Stephen Hawking. I am dope like LSD.
Hello everyone. Twinbeard back in the Sleep Creek Pirate Broadcast Laboratories. And I'm at it again. We've made some improvements to the FlowerPower device. So I'm going to show those to you. And I'm going to do you a little preview of some work I'm doing that we'll be rolling out here before too long. Okay, so here's our scope trace here. As always, we're on 50 volts per vertical division there, and we're set at 10 microseconds per horizontal division. So I'm going to crank this down here, right about there somewhere. And then we got a little more, so we got somewhere around 1,000 volts, maybe a little more going here. Right there to right there to right there or so. And take a look at our ammeter over here. We've got 0 on the left, 6 on the right. We're set on a 6 amp scale. And I'm showing about 700 milliamps, somewhere in that neighborhood. We're going through a 2 ohm load with the output of our transformer here, which is being driven one wire style by the FlowerPower device. Now, what did I do to increase my output? Well, very simple. I got some new toys. I picked up some 1/8 inch N42 rather neodymium spheres. It's the smallest one I could find anywhere on the web, anywhere around. If anybody knows of a smaller neomagnet trying to escape, let me know. I also picked up several other magnets here that we'll be using in various assorted research. We've got some 1/8 inch diameter diametrically magnetized cylinders. We've got a 1/2 inch of the same. We've got a 1/2 inch sphere. We've got a 3/8 inch sphere, and we've got some more 1/4 inch spheres there, but those are gold plated. As you can see, several of the small guys. To test with. So that was it. I kind of put that rotor in there, replacing the 1/8 inch rotor. I'm still using a similar style of housing made out of the same acrylic. But I'm working on a couple different methods for a better housing. I might just get a rod of this acrylic and drill a hole and make my own cylinder to match the size that we need. But here are the first couple of stabs. I essentially layered up stacked up a few layers of this Lexan here to make these guys. And then I drilled a hole through it, and I put the magnet in. This one I kind of tried to drill a mostly sealed compartment in there with just some air holes sticking out. This one worked pretty well for a while until the Lexan melted, or until the Lexan melted away in one part, and now the rotor likes to get stuck kind of in the edge. So we'll live and learn from that. This one I haven't spun up yet, just because I'm enjoying this nice whistling sound of the air moving from the current rotor housing that I have going. But not to worry, we do have the titanium housing in the works. So I told you we'd show some things that we're going to be working on here soon. Here we have a pair of monofilar starships. Those are going to fire out of phase. I'm going to try to create a counter-rotating vortex in there. And we'll wind up putting one of or more of these rotors right smack in the middle and see how it works out. We're going to drive that with these IGBTs right here. These are Fairchild Semiconductor 1H39SBs. And then I've got some H11D1 optocouplers here that we're going to tie that into this Arduino with. And essentially what I'm trying to do here is we're going to be pulsing both sides here, so pulsing both sides out of phase. So we're going to be pumping a square wave into this through our IGBTs, our optocouplers, and perhaps our gate drivers. I'm not sure. I don't think those have a quick enough rise and fall time to get the effect that I want. So I might just wind up going straight out of the optocoupler into this little PNP right here and driving the IGBT with it. But this thing right here will allow us to modulate the variables of pulse width in the form of duty cycle and frequency. And then we'll use several different rotors in there to see what kind of effects we get. Should be a pretty interesting experiment. I've been putting this together for a little while now. It's kind of just sitting off to the side of the desk. And I finally got around to winding the second coil. Got a very ugly rudimentary schematic here of what's going on. So once I build this device, I'll make a nice schematic. I'll publish it for you guys, and we'll release some code as to what's going to be driving our Arduino there. But we're essentially just going to be using the pulse width outputs, the pulse width modulation outputs of that device. Alright guys, I think that's all for now. Just on another side note there, we're hitting about 57,500 hertz here. I've got that on 10 microseconds, rather 10.1 milliseconds. Per division, and to get an accurate sample, because we have a little skew there in our distance between our waves. If we kind of put our position here and put one peak directly on the left division line, then if we look at the whole thing here, we wind up with 57.5 full waveforms, which matches up with the calculations I did over here. You'll notice it's a much cleaner wave too. What I realized was that we had the field of this motor and these motors over here interacting with the field of our rotor in the FlowerPower, which was kind of causing those waves to bounce around. So as you can see, this waveform is quite a bit clearer now. That's just with the single FlowerPower running. Alright guys.